So here we are with part 3. I'm in a blank project, so I'm just going to go move, new, and we call this just move 3. Cool. And first I need to move into 3. Yeah, now we're in there. So we have our usual project with the move toml and our blank sources. So inside sources, I'm going to create a new file, and we're going to call it company.move. So we're going to create this kind of pseudo important module, perhaps like, let's say we want to have a company on chain, not a DAO, just going to do some very simple basic stuff. So first of all, I'm going to create the module and the 0x42 just for good time's sake. And we're going to call this company. Just to say that if you were actually working on testnet or something, this would have to be your real address, but we're not moving into that. We're just talking local development, writing modules, testing them out, learning stuff. Let me disable. Cool. So what are we going to do here? Well, we're going to write this contract, and it's going to be of type address, and we're going to have this 0x42. So what is this? We have a constant using the const keyword, and all constants in move have to be named in all capitals. So we name this contract, and then we give it a type, and it's of type primitive address. So we actually have primitive types in move which are address types, and when we have a value for an address type, we have to append it with the @ symbol, and then we write the address. So this const contains this address, which is the contract's address. I've called it contract in this instance, but you could call it something like module, account, whatever. But let's just call it contract. I know it's not quite move terminology, but that's fine. So this const cannot be altered. The value of it cannot change during the whole lifespan of this module. So that's a constant there. And we're going to have this struct as well. And we're going to call this struct employees. And let's just leave this as a blank struct for now, knowing that we're going to update it in a bit. And we're going to have struct employee, a single employee. And it's going to have a few things. It's going to have the name, which will be of this vector, vector U8, which we looked at last time. Age will just be a straight up U8. And income, we're going to say the income, and that's going to be of type U64. So U64, difference between U64 and U8 is the same idea as in Rust or Go or C, where you have more memory allocated to this unsigned integer. It's also worth noting that move doesn't natively support yet signed integers. So that means that natively on move we can only work with positive numbers, not numbers below 0. There are frameworks that have been built to deal with negative numbers if you wish. So that's something worth noting. So now in this people struct, in this employee struct, we're going to have a field called people, and of course it's going to be of type vector, and the vector is going to have each element filled with an employee. Okay, cool. So public fun create employee. And we're going to have my friend, and my friend is going to be employee, and we're going to have employees, which is going to be mutable employees. And this is going to return our employee, very similar to how we had a create friend thing before. Pretty much the same idea here. And let's write this. So let new friend let new employee, and it's going to be of type employee, and we're going to have the name, and the name is going to be, I called this my friend, didn't I? So let's just call this employee, and I use the underscore there. It's a kind of coding convention. If the variable name, if the parameter name is the same as the type name, we can put an underscore at the beginning to denote the difference there. Employee dot name, and age is going to be underscore employee dot age, and income is going to be underscore employee dot income. Cool, so there's our new employee, and then just like before, we're going to have a method here called add employee, and this will take in the new employee, and this will have employees. Cool, and then we're going to return our new employee. Nice. Oops, typo there. Alright, awesome. We could write a test for it. I mean, if I was coding this from scratch, I would write a test for this now and test that all of this is working. But let's just go ahead and write out this entire module and then write the test and debug it and see how we go. So let's do, well, we're going to need that employee. And this doesn't actually need to be public because it's just going to be called internally by our function. So this is no longer public fun, this is just fun. So we just add employee, yes. And this add employee, we can do it slightly differently to how we did it before. We can just have this employee, which is of type employee, we know. And inside this function, we're just going to have the vector, push back, and we're simply going to push back. The pushback requires two things. The mutable reference to the vector that already exists and the element that you're wanting to push into that. So we need @mute employees dot people, right? Because the field of people is the vector, and then simply employee. Cool. But we are not importing the vector yet from the standard library, so let's do that. Use std. So now we can have this method available to us, the vector method. Cool, so let's add a few other methods just to have some fun here and sort of do stuff with move, very basic stuff. So we're going to increase income. Okay, cool. So here we've got increase income, where we take in two things. The employee, which is of type mutable reference to employee, so we want the immutable reference, and a bonus, which is of type U64, and it's going to return the altered employee. So what are we going to do here? We're going to go employee.income equals employee.income plus bonus, right? And we're just going to return the employee. So basically we're getting the income and we're setting it to the income plus bonus. So we're adding the bonus to the income and then returning it. If these were not mutable references, we would see some errors here. You could try out removing this mutable reference, writing a unit test and calling it and seeing what happens. But I'm just going to write it the correct way first, and then we'll see as we go through, we'll understand deeper the meanings of all these things. So now we're going to do another one. Okay, cool. So we've written some methods here. This should be public. So increase income, decrease income. So we've written some functions here, all public, increase income, decrease income, multiply income, and divide income. So these are just some silly functions really, but just to show us these operators that we have available to us. We have the plus, minus, multiply, and divide. These are all types of UN64s, and yeah, that's pretty straightforward what these functions are doing. Now let's write another method. So notice in this function signature, I just want a reference to the employee. I don't need a mutable reference, which means that this employee is going to be immutable, which means I cannot change it. I just want to get the value. I don't want to set anything or update anything. So by just using the reference, it's immutable. So let's write a few things here. So here we're checking if the employee's age is even. So first of all, we declare this variable of type Boolean, and then we have this if check, and we have to put this if check in brackets in move. If the employee.age divided by 2 has a remainder of 0, that means it's even. So set is even to true, otherwise set is even to false, and then return it, and that's why we return our bool here. And we are missing the code on there. Cool. So at this point, we're ready to write our unit tests to test out all of this code. So let's go ahead and do that. Cool, so we've written our first test. Let's run it. Let's try that again. So we've got unexpected add employee. So usually that means that I've missed a semicolon somewhere. So that's on line 23. And true enough, there it is. Unexpected return, same thing, line 60. Yeah. So invalid variable usage, unbound variable, typo. So 17. Incompatible types. Created employee Richard.name. Invalid call of assert. So it's just a typo, I forgot the double equal there. Too many arguments add employee, so line 23. True, that just takes the new employee. So we got rid of that area, now one error left. Invalid variable usage, unbound variable employees. That's on line 28. So I think I need to pass in employees here. Which is going to be to pass it in here. Like this, employees, Let's try it. Invalid variable usage. Same again. Yes. We need to add the underscore, so it's getting the parameter value. Let's try it. Employees does not have the ability. Drop. So basically we're dropping it at some point, and we need to say abilities on here. So actually I want to add a whole bunch of struct abilities. I want to say it has store, so we can store it. It has key, it has drop, and it has copy. And employees is going to have store, key, and drop. So we're basically just not handling this like a proper valuable resource, and we're just dropping it at this point. Let created employee. We're not doing anything with this created employee after that. So we need to allow it to be dropped. Boom. So there we go. Our test is passing now. So this create employee method is working. So let's continue with our unit tests. Okay, so now we're going to write a unit test to test our operators, our simple math functions there, where we increase and decrease income, things like that. So first of all, we're going to write this function test. Created employee, and we're going to do create employee increased employee income. Why not? Increase income. And that takes in a mutable employee, reference to a mutable employee, and a number, which is going to be, we'll pass in 100. So we want to assert that because we're increasing it by 100 and the original income is 100, we want to check that is equal to 200, right? Because originally here it was 100, and we want to check that it's 200 because we're increasing it by 100 here. So just missing a semicolon as usual, and also here. Boom. So that test worked. So let's just try and force this to be some weird number like 189, and it should fail. Yes, and it fails. So looking good. Let's write the other tests. So here are the other tests. We've got test decrease income, and then we have test multiply income, and then test divide income. We also have the test for is employee age even. So let's run all these tests, and they all pass. So I thought there'd be no point in me really showing you me writing all these tests because they pretty much follow the same pattern. So have a go running these unit tests yourself and get them all to pass. I will see you in the next video.